Hello, and welcome to PyOhio 2020. In case you're not familiar, PyOhio is an annual, free-to-attend Python community conference based in Columbus, Ohio. It is planned by a group of volunteer organizers and is typically hosted in Columbus in partnership with the Ohio State University Open Source Club. This year's format is obviously very different than usual. When planning for the conference, the organizing committee recognized that folks are exhausted. And yet, we heard from people in our community that they still had ideas to share and the desire to connect over PyOhio weekend. We decided that a pre-recorded short talk format would be the best way to allow folks to share their ideas while respecting everyone's limited energy at this time. We hope that you're able to use the talks and conversations from this weekend to recharge and find inspiration for the work that we all have ahead of us. We want PyOhio to be a safe and welcoming place for people to be able to learn and grow. To help ensure that this is the case, we've adopted a code of conduct that you must agree to adhere to in order to participate in conference events. Please take time to read the code of conduct at pyohio.org/conduct. If at any point during the event you are being harassed, notice someone else being harassed, observe other inappropriate behavior, or have other conduct concerns, please contact conference staff. In Discord chat, you may do so by tagging @moderator in an open message or direct messaging anyone in the highlighted moderator group, or you can email conduct@pyohio.org. In either case, we will reply and attempt to address the issue quickly. This contact information is on the website and in the README of the Discord server. We have created a private Discord server for use during PyOhio. It requires a free PyOhio conference registration using the same email address as your Discord account. You may still register for the event now. If you've already registered with a different address, you can register again. There is no need to cancel your duplicate registration. For more details and for the server invite, visit chat.pyohio.org. Talks will be streaming in 2 blocks. This one will run until about 11 a.m. Eastern. There will be a break, and it will start again at 12 p.m. Eastern, running until about 2:30. Talks will be streamed in groups with about a 5-minute break between groups. A detailed talk schedule is available at pyohio.org. While the talks are happening, you can join us in conversation in the Streaming Talks discussion channel on our Discord server. Please note that due to limitations of our streaming setup, we weren't able to configure captions on this stream. We do, however, have captions on each of the individual videos on our YouTube channel. Direct links to each of the videos will be provided in Discord as they're about to start streaming, so you can follow along that way if you wish. Sprints are a chance to collaborate with other attendees on existing open source projects or even create new ones. They're typically in person, but the virtual format is still a great way to get new folks onboarded as contributors or just discuss open issues. To see the list of sprints or to organize one for yourself, see pyohio.org/sprints. We'll create a Discord channel and provide a video conferencing link for you if desired. Open spaces are scheduled times to discuss topics you think might be of interest to other attendees. If you'd like to schedule one of these sessions, please post in the Open Space Proposals Discord channel. We'll create a new channel for your open space and can create calendar invites with video conferencing links for you if desired. We typically use our t-shirt sale to help fund the conference itself. Because our costs were low this year, and because we weren't able to run our Young Coders classes, we decided to use the fundraiser to benefit an organization that furthers our mission. 100% of the proceeds from the t-shirt sales will go directly to Black Girls Code. You may also make a donation without purchasing a t-shirt if you prefer. Note that the shirts come in 3 different cuts and the sizing varies, so be sure to check the sizing charts. The sale will be open until July 29th, and the shirts will ship approximately 2 weeks after the sale ends. We'd like to thank everyone involved in making PyOhio happen this year. Thank you to the speakers and everyone who took the time to propose a talk. Thank you to the volunteer organizers who put in countless hours behind the scenes. Thank you to everyone who donated through the conference registration site. We were able to cover our costs this year without any corporate sponsors. Thank you to everyone who bought a t-shirt or donated to Black Girls Code. Know that your money is going toward a great cause. And thank you to everyone for taking the time to watch along and join us in chat this weekend. Once again, welcome to PyOhio 2020. We really hope that you get something meaningful out of your time this weekend.
Hi everyone, excited to see you all virtually at PyOhio 2020. In this Thunder Talk, I will address how to map data with GeoPandas by using data from Pittsburgh's Healthy Ride bike sharing program. I'd like to make note that this data is open source and you can view my analysis on my blog or view my Jupyter Notebook on GitHub for a more in-depth tutorial. I'd like to make a shout out to the open source datasets out there, or else this project would not have been made possible. The data used in this project comes from the Western Pennsylvania Regional Data Center, as well as the Pittsburgh GIS Open Data datasets. A little motivation behind this project I like to do projects with open source data related to socio-technical systems, which mobility and transportation are one, so I chose the bike sharing system in Pittsburgh. I also know that certain neighborhoods in Pittsburgh are low-income neighborhoods, and I have previously done a lot of research on bike-sharing programs in cities that are of similar size to Pittsburgh. Take St. Louis, for example, with Lime Bikes. They have a similar population size to Pittsburgh, but they are working very hard to make their bike-sharing system accessible to low-income neighborhoods by including pay stations for people without smartphones. Or Manizales, Colombia. Their bike system is free for residents and based on biometrics. For starting off this project, you will need to find some datasets. Here are some general guidelines. You will need at least one dataset that is .shp file type, also known as a shapefile. Shapefiles contain data such as points, lines, and polygons that can represent features such as elevation, city borders, bus stops, locations, etc. Sometimes it is the case where your shapefile also has the categorical or quantitative data that you want to map. Other times, you will need to find another dataset containing the data you want to associate with your spatial data. This is my case, where I found the Healthy Ride dataset, but it was not in the form of a shapefile. It had longitude and latitude values of bike station locations, but it was just a regular CSV file. So in this tutorial, I will walk through how to turn a regular CSV file into a geodata frame and then plot that on a map. For this tutorial, you'll need to import GeoPandas, pandas, as well as some libraries for creating points and polygons. If you don't have any of these libraries installed yet, go over to your terminal and install them. Next, we can load in the data that we are going to use to make the map. I have one CSV file, which consists of the locations of the Healthy Ride station locations, and then I have two shape files. As I previously mentioned, these files will contain points, lines, and polygons to make up, say, a city outline of neighborhoods. It is important to make note here that I am turning the shapefiles into GeoDataFrames using GPD. One shapefile is of the census tracts in Pittsburgh, and the other one is of poor housing conditions by census tract in all of Allegheny County. This allows us to perform geospatial operations on vectors, or a geoseries, which makes up a geodata frame. For more information on these geodata frames, visit geopandas.org for their data structure documentation. Once you have your data loaded in, you can now plot your geodata frames by just calling them the name. So we have CenTrack. You can call CenTrack.plot, and it will show you the resulting map or shapefile. In this case, it shows a map of Pittsburgh with outlined census tracts of 2010. As we all may know, cleaning the data is super important. With the Healthy Ride dataset, there was one row that had a negative latitude instead of positive, so it was putting the bike station, say, in South America or Antarctica, somewhere really far away, on the other side of the globe. If you have a dataset with only longitude and latitude fields, and not as a shapefile, you'll want to make sure the data points will map correctly. You can check this by plotting your pandas data frame on a scatter plot. I know generally where all the bike stations are in Pittsburgh, so make sure that all the coordinates of the entity you are mapping match up. After cleaning my data, we can see that the bike stations map out right. If you're familiar with Pittsburgh, there are 3 rivers that converge to a point, and this general shape can be seen here. Now from this pandas data frame, we can take the longitude and latitude and use the Shapely library to create a point to give this data some geometry so it can eventually be turned into a geodata frame. To create the point, we will zip the longitude and latitude points from our pandas data frame into a point. Here's where GeoPandas comes in. We will now create a geodata frame from the original data frame. The defined coordinate system from the northeast area and the geometry that we just defined for making the points. So we have 3 parameters that we're calling in here, and make note that we're calling gpd.geodataframe instead of gpd.readFile like we did on the shape files. This is very similar to pandas when you would call pd.dataframe and send in your data. So here we have our original data frame, a coordinate system. If you're not familiar with the coordinate system of your local area, you can search up this on Google to find out and enter in the city that you're located in. And this is the geometry, which it could be a point or lines or polygons. Let's map out the geodata frame head to make sure all of the columns match up right, and then we can move on to the next step. You can now also plot this geodata frame just as we plotted the others. This is known as an overlay. Maps tend to have several overlays. Some can be points, lines, polygons, shadings, multiple different points, etc. But before finishing our map, we have to do some more data cleaning. Next, we need to take our base map, which is the census tracts, and shade each census tract based on the percentage of poor housing. The poor housing conditions map was for all of Allegheny County, and I only wanted Pittsburgh. So I just stripped the census tracts and poor housing data from that map and merged it into the Pittsburgh census tract shapefile I have. As you can see, the top 3 lines here are doing so by taking the poor housing conditions column and the census tracts column and merging them into my other data frame. Finally, we need to create a CHOROPLETH map. A CHOROPLETH map is good for associating polygons with a range of colors depending on a quantitative variable. This step is pretty simple. It is just 1 extra parameter that we have to add when plotting the map. I'll break up the code a little bit though. So the first parameter, we have the column equal to p poor con, which is what I had set that column to in the last slide when I made a new geodata frame. This will be used in the map to map out the values with a color. The CMap color, you can choose whatever you want, just take a look at the matplotlib for this. You can set the figure size and set an edge color. It is good to have an edge color because some census tracts, in my case, had the same percentage of poor housing conditions and they overflowed into one another. And here we have our CHOROPLETH map based off of our base, which will be our base map, and these colors are based on the poor housing conditions values. Now the final step is to plot the overlays on top of our base map. Make sure that you set the axis to be the same axis as the one you put for your base map. You can change the marker size or the color. I used violet so it could stand out. And we combine them and voila! You have your map. I'll warn you the power you have now over making maps. Do not present misleading maps. These maps are meant to provide insight and analysis in a geographical way. If you'd like to see more on this analysis, you can check out my Jupyter notebook here on my website or on my GitHub. Thanks. Here's the full code that made this tutorial possible. My GitHub has a fully fleshed out another analysis on the number of bike racks at each bike station as well. I'd like to make a shout out to carbon.now.sh for hosting such an awesome platform to integrate my code into my slideshow. I'd like to thank you all for watching and thank the PyOhio supervisors for still hosting this awesome conference despite the current circumstances. If you'd like to reach out to me for any questions, head over to my GitHub page and send me an email. Thanks.
My name is Ali Sivji. You can find me on Twitter at KaiaSivjus. I'm one of the organizers of the Chicago Python users group. We call ourselves Chippy. There's a lot of material to cover, so let's just get started. A point about notation, you're going to hear me say dunder quite a bit in this talk. This means double underscore. For example, when we have double underscore init double underscore, we can shorten that down to dunder init. In Python, everything is an object. But what does this really mean? An object is an entity that has data and that has behavior. We can create objects from classes, and each object instance has values associated with it. Going up a level, when we take a look at the type of object that we created, we can see that it's the class that it's derived from. And this is true across the board. Strings are str objects, integers are int objects, lists are lists, and so on and so forth. In Python, everything is an object. So this is great and all, but what's my point? Guido van Rossum, the creator of Python, wrote, "I want all objects that could be named to have equal status." These objects can be assigned to variables, placed in lists, stored in dictionaries, passed as arguments, and so on and so forth. Another way to say this is that objects are first-class citizens in the Python programming language. It shouldn't be a huge surprise that functions are also objects. Specifically, they are objects of the type function. And since this is an object, we can pass them into other functions. So is this useful? Turns out it is. Say we have a list of movies we want to binge. We can use the built-in sorted function to get these movies in alphabetical order. But if we want to binge the greatest movie series of all time in the order it was released, we're going to have to sort them in a different way. So we can do this by passing in a function specifying how we want to sort our list. Here we're going to specify that we want to sort by the release year attribute inside of that named tuple. All of this, it got me thinking. If objects are created from classes, but everything is already an object, what do we really need classes for anyways? In this talk, we're going to conduct a thought experiment. We're going to write some object-oriented code without any classes. So let's start with a quick review of object-oriented programming. Classes are templates that allow us to create objects, and we can access an object's attributes, that is, its behavior and its data, using dot notation. Objects have data, and these are values that are stored inside of the instance dictionary, and we can retrieve this dictionary using the instance dunderDict. Objects also have behavior, and we can find this information in the class dictionary. This dictionary contains built-in methods and custom methods that we just created. Our example throughout this talk is going to be building a chess engine. Chess is a game that has 2 players, an 8x8 board with ranks or rows numbered 1 to 8, and then we also have files or columns labeled A to H, and we have a bunch of pieces. And there's a bunch of different pieces, they move a bunch of different ways. For our purposes, the game is over when the king is being attacked and has no place to go. So let's just write some code. We're going to start off by creating a class for our piece. No, wait, scratch that. We're not using classes. Sorry, it's just a bit of force of habit. We're going to start off by creating a function called piece that takes in a color. And just like what an object does behind the scenes, we're going to store this information inside of a dictionary. And then we're going to close this function by returning that dictionary. If I was designing an object-oriented solution, piece would be my base class, and then I would create all of my other piece types using that base class. But how can we replicate inheritance hierarchy with just functions? We can use functools.partial. So functools.partial, it's going to take in a function and some arguments. This could be positional or keyword arguments. And it's going to return a partial function. And this partial function freezes that function we pass in with those function arguments or those function keywords. And then we're going to reduce our function's signature. It's just going to simplify it. So how does this help us? Going back to that example, we can update our function to accept a type argument, and then we can add that argument to our internal dictionary. And just like before, we're going to return that dictionary. And now we'll use functools.partial to initialize our piece with the type equals queen. And the resulting partial object, that's going to be saved in our queen variable. Now we can create a queen piece and access its attributes using the dictionary notation. We just implemented inheritance with functions. This is great, but dictionary style access, it feels a little bit weird. It makes sense since our underlying object is a dictionary, but is there any way we can hack together attribute access? Enter types.simple namespace. This is an object that provides attribute access to a namespace. If we initialize simple namespace with keyword arguments, those are going to be directly added to our underlying namespace. For example, if we have a dictionary called data, we're going to import simple namespace, slap that dictionary into that constructor, and now we can actually go out and use dot notation to access those attribute values. Jumping back into the code for our piece function, we'll wrap our dictionary inside of a namespace, and then we're going to return that back to the caller. Now that we have that piece function that behaves like an object, we can create all the piece to objects that we need to initialize our game. So the next step is to set up our game board to initial state. In chess, this looks as follows. So we're going to start off by creating an empty dictionary. We're going to cycle through each of the squares on our board, set their values to none. Then we're going to just put all the pieces where they belong. So here we're just going to initialize all of our white pieces. Next, we're going to initialize all of our black pieces. Finally, we're going to return our dictionary that we just created. Now we can start our game. The object that we got back, it looks like this. It doesn't really do us any good. Our users are probably going to want to see some sort of graphic representation. So let's take a look at that. Fortunately, characters for our, the chess pieces, they're available as emojis. So we can just create a simple mapping table. And now our drawBoard function, it's going to take in a board. We're going to cycle through all those squares inside of our board. And then for each character, we're going to add it to our string. And then finally, we're going to just print the string we just created. If we run our code, it looks like this. It's not as nice as the example from earlier, but it's pretty good with just a few lines of code. Taking a step back, let's take a look at that drawBoard function. If we look at that function, it's pretty indistinguishable from object-oriented code. The only way we know that this code doesn't use any classes is by going into the implementation. We still haven't implemented piece movement, but we're running out of time. I won't be able to talk about things like inner functions or closures, but I did include links later on that you can use to check out at your leisure. What can I say? Estimating things, it's a little bit hard. I hope to write up a blog post or maybe a lightning talk at next PyOhio. So let's recap. Using built-in data structures and the standard library, we can write functions that mimic the behavior of classes. This is great, but our code, it's a little bit of a mess. You never really want to do something like this in production. Recall from the Zen of Python that simple is better than complex. If we're doing all this work just to replicate the functionality of a class, why don't we just use classes to begin with? I also want to note that we don't have to dig into C Python source code to understand the internals of Python. If we just introspect our objects, we'll get a lot of insights into how Python functions underneath the scenes. One of the things I learned was that objects, they're just nice wrappers around dictionaries. And the more you dig into Python, the more you see that dictionaries, they're one of the primary data structures inside the programming language. Here are links to some additional resources. So thanks everybody for your time. I do want to give a shout out to Chicago Python. I would not be where I am without that fantastic organization. So thanks again. My name is Ali Sivji. I'll see you all in Columbus for PyOhio 2021.
Hi, PyOhio. Even though I'm super sad to not see you all in Columbus this year, I'm grateful to be able to catch you all virtually. So let's talk about the Python Software Foundation. The PSF is the nonprofit organization behind the Python programming language and its global community. In essence, we are here to support our community, core developers, and help promote Python in any way possible. The PSF has 13 board directors, and the directors set the strategic path for the PSF. Additionally, the PSF has 7 paid employees. Some of us work on management, some of us work on PyCon, some of us work on infrastructure, and 3 of us work on finances. And we help execute the board's strategy. Most importantly, the PSF has hundreds of volunteers. Volunteers take part in PSF work groups, volunteers help with outreach and education, volunteers help actually code Python, volunteers organize events, and do so much more. I won't go into too much detail about what the PSF does since I do have limited time, but I did want to just briefly glance over a list. So we apply for and maintain related trademarks. That includes Python, PyCon, PyLadies, even PyPI. We produce PyCon US. We give out grants. We support community infrastructure. We house projects through our fiscal sponsorship program. And we house several working groups. If you'd like to learn more about what the PSF does, check out these bit.ly links. The first one here will take you to a more in-depth slide deck. And the second one will take you to our annual impact report from 2019. Like so many other organizations, the PSF has had to shift its focus recently. As many of you know, in March, we were faced with canceling PyCon US. PyCon US is very important to the PSF sustainability because it generates 63% of the PSF's revenue. That revenue is that we receive from PyCon is the money that is used to run the PSF and all of its programs that it provides to the community. Additionally, it is one of the few times of the year where the PSF staff and directors can meet in person to progress on projects and discuss ideas. It is also one of the few times of the year that PSF has a chance to hear from our community, either through one-on-one discussions or even through the hallway track discussions. Even though we were able to pivot to PyCon 2020 online last minute, we still lost lots of important interactions and momentum. But regardless, PyCon 2020 online content is still up and available, so check out us.pycon.org if you want to check out some of those talks. And it is no secret that canceling PyCon did have a financial impact on the PSF. Thankfully, since 2009, the PSF has been working on a financial reserve to help us prepare for once-in-a-lifetime events, such as a pandemic. Initially, we expected needing over $600,000 from our financial reserve just to get through this year. Currently, we're estimating that we'll be able to break even, and this is thanks to PyCon Online sponsors and also individual donors who switched their registration fees to donations to the PSF, as well as other great partnerships that help us fundraise a lot of money throughout the year. But the goals that we had initially set for 2020 and beyond have become stretch goals, and we've had to shift our focus a bit. Supporting the Python community remains our #1 priority, even if we have fewer resources, even if things are changing a bit. Some of the things we are working on include preparing for PyCon 2021. There are so many unknowns around in-person events right now, and that even stretches into 2021, honestly. We are in process of revising our grants program for the rest of 2020. We want to be able to continue to support events, virtual events, of course, but we want to use all of the resources that we have to allow the community to do what they want to do. With in-person meetings being canceled or going virtual, we are discussing diversifying our revenue stream now more than ever. This includes discussing how we can apply for outside grants to help us achieve some of the goals that we have. And of course, we are going to concentrate a bit more on corporate sponsorships. These types of partnerships are so vital to us right now, and we hope that establishing these will help us do some of the goals that we had, such as supporting core development, which is really important to the sustainability of Python. Lastly, we want to emphasize the importance of maintaining what we already have. We always try to achieve this, but now it's more important than ever. And we want to do this by continuing to recognize volunteer efforts, supporting volunteers, and taking care of our staff and directors. So if you ever see a call for nominations for fellow members or community service awards, please do nominate folks that you feel deserve the recognition. If you'd like to get involved, we'd love to have you. I created this page that lists about 30 plus ways someone can get involved with the PSF. It ranges from just keeping up to date with the PSF news and to things such as asking your employer for financial support through a sponsorship of the PSF. Check out the bit.ly link for the full list. Thank you all so much for this opportunity. The chance to share what the PSF is doing is crucial to our sustainability right now. Please enjoy the rest of the lightning talks and thunder talks, and I hope to see you all in the near future. Please stay safe as well. And of course, if you have any questions, don't hesitate to contact me via email, ewa@python.org. Thanks all.
Oh, hi-oh, didn't notice you there. I was just writing some Python code and I've noticed that it's surprisingly slow. But maybe it's just me and my code is not really slow, so I have to figure out a way to measure it. So I was thinking, well, I often find myself in a situation where I want to see how slow some code is. I would love to have a function that will measure it for me, and not something that I have to actively run for the measurement, but just something that will run automatically. Oh, and I want it to be integrated into my Python shell. And there is a perfect tool I can use for that. I can write an extension for IPython. Some of you maybe never heard of IPython. Well, if you know Jupyter Notebooks, then IPython is this cool Python REPL that powers it. In general, IPython is a Python REPL, but it's much better than the built-in one. Since it's a drop-in replacement for standard Python REPL, you can just install it with pip, and then you just run IPython instead of Python. And pretty much that's it. You have all the commands there, you have some syntax highlighting. IPython has a ton of cool features, and I covered a lot of them in a video called Wait, IPython Can Do That. One of those features are extensions. You can write an extension that, when loaded, will modify any part of IPython. You can define some custom key bindings, you can define some events, etc. In my case, I want an extension that, when activated, will print the execution time of each command that I run. And just to make it a bit more interesting, I've decided to write this extension without leaving IPython. So we start IPython and we can't quit until the extension is ready and working. It's probably not going to work, and I would never try it while live coding, but this is pre-recorded. I promise not to cheat. So how do we make an IPython extension? Well, first we need to create a new file inside the .ipython/extensions directory. That's the local extensions directory. So if you put some files there, IPython will be able to load them with the load extension command. So the easiest way is to move to that directory. And with IPython, you can actually execute shell commands by adding exclamation mark. So let's give it a try. And for most common shell commands, you don't even have to add the exclamation marks. So now that we are here, we have to create a new file. I'm gonna name it timer. And to edit our new file, we can either run vim or we can use the edit magic command. I like the edit command more because, first of all, when you use it and you close the file, IPython will automatically execute it. And next time you want to edit the same file, you just use edit with -p parameter. So you don't have to remember the full path to the file. So how is our timer going to work? Well, I want to start the timer, execute a command in IPython, stop the timer, and then print how long did it take. For this, I can use something called events. IPython events lets you plug some callback functions that will be executed before or after the cell is executed. So since I have to store this time somewhere, I'm going to use a class to encapsulate my events. So we start with a class. Okay, so we have our function, and you might be wondering, why do we have this info and result parameters that we are not using? Well, IPython events expect a certain signature of a function. So if you want to have an event that will be called before a given cell is run, it will always provide you with information about a given cell. And the same for the event that is called when after the cell is run, you will get an argument with the results of that cell. So we have a class, and now we actually have to register those two functions with appropriate events. To do that, we need to define the load IPython extension function. This is the function that will be called when we load our extension. And inside that function, we register two events. First, we register the before function of our timer as the pre-run cell event, and then we register the after function as our post-run cell event. So we can close this file and load our extension. And you see that we get an error, although the extension seems to be working. That's because when we loaded the extension, the after function was executed, but before function was not. So self.timer is set to none, and we can actually go and fix it with a simple check. So we go back and edit the same file as before. And now we just check if self.timer is defined. If not, we don't do anything. If it is, we return how long it took to execute some command. So we can close this file. And now we can reload our extension. And now it's working fine. Except that now we have two extensions loaded because we didn't define a function to unload our extension. So now each time we load our extension, we're gonna register those two events over and over and over. And while it looks funny, it's not very useful for us. So let's write another function to unload our extension. As you may probably guessed, to unload an extension, we just have to write unload IPython extension function. The only problem here is that this code won't work. You see, that's because this t before callback that we register in the load function is not the same as the t before callback that we try to unregister. So to fix that, we can, for example, move the initialization of the timer outside of the load and unload function. So we'll be creating only one instance. So that's our final version of the extension. We can close it. Whoa, that took us some time. And what happened if we reload? You can see that we are no longer loading new extensions, but we still have those 4 extensions that we loaded before. You could get rid of them by just starting a new IPython. But as I said, we are not going to leave our initial IPython session until we get a working extension. So what can we do? Well, everything in Python is an object, so I can just dig inside the internals of IPython and try to remove the callbacks manually. It sounds more complicated than it is. So first we need to get the IPython object. Now we look inside the events. And actually events is an event manager, so we can assign it to a variable. And now we can look inside the callbacks. And you can see that callbacks is just a dictionary that maps a given event to a list of functions that will be called. So all we have to do is to just go and clear both the pre-run cell and post-run cell lists. Okay, one more to go. Perfect, no more timing. And if we try to load our extension, reload, you can see from this scary stack trace, IPython still thinks that our extension is loaded even though we manually removed it. So hopefully last thing we have to do is to go to the extensions manager and manually remove it from the list of loaded extensions. As you can see, it's here. And hopefully that's it. So let's give it a try. It used a very old start timestamp, but that's okay. And let's give it a try. This is working. And can we actually unload it? Perfect, it's working, and all that happened in the same IPython session. Crazy, I didn't think it's gonna work. I hope you enjoyed this short presentation. There are a lot of cool things that you can do with IPython, so if you're interested, you can go check the documentation or watch my presentation where I go through most of them. Take care and enjoy the rest of PyOhio conference.
A day has only 24 plus or minus 1 hour, and I have less than 10 minutes to speak about it. My name is Miroslav Šigivi. I was born in Bratislava, Czechoslovakia, studied in Lyon and working now in Karlsruhe all around Europe, but still in the same time zone. I will tell you how to check the current time in Python and that you should check what your government does. If you want to check the current time in Python, you can call datetime now. That will return a datetime object with all the information contained. But this will be just like that only for you if you are in Ohio or around. If I do that on my computer here in Germany, my datetime object will be 6 hours ahead of yours without the information that I'm actually 6 hours ahead of you. If your computer is set to UTC, you will get another datetime object. So now you have 3 datetime objects that were created at the same moment, but that contain different information. If you want to get always the same time, you can ask for UTC now. Or even better, for now, with the UTC time zone parameter. That will be the same on every computer. The advantage is that now you can calculate actually with time zones. In the first 3 cases, you were not able to do that. If you want to know the current time in Ohio, you can tell, okay, we are 4 hours behind UTC, so I'm going to define my own time zone 4 hours behind the UTC, and you will get the current time. But the disadvantage is that in summer and winter, it will always be the same and not respect your daylight saving time. The best way is to ask for some library that will know your time zone. You are now located in America, New York time zone, and that will calculate it. PyOhio is one possibility. Another possibility is the new PEP 6015 that zone info module that will allow you to get the current time with the information about time zones located directly on your computer. What are time zones? Before railroad, they didn't make really sense, but when you have a railroad and you have 2 cities with different times, you don't want to send 2 trains at the same time on that one track. So there was Greenwich and around the world 12 plus 12 minus 12 time zones, which later with political decisions changed into more than 400 time zones. So these are the same color is the same time. So now you see the purple US, you have the same time zone as most of the Caribbean and the center of South America. Where does this information come from? There is IANA organization that does not decide, they only monitor the time zones information and they put it into their database. And every year there are a few versions that you can download for free. And what you will find in this module or this archive, there are a few programs, Perl, Oak, Shell, and the most interesting information are all the files that are called Africa, North America, Europe, and so on. So for example, for North America, you see 160 kilobytes of text information. There is some computer readable information for the time zones changes and a lot of text that comments this. On this IANA or time zones website, there is also a mailing list that contains a real, like a book, the whole information, the whole discussion about when what changed in the history of time zones. If there is one picture from this talk that you want to take this one. This is the history of all 440 time zones around the world. On the x-axis, you see the years, and on the y-axis, it is the offset. So 0 is Greenwich. This is Europe and Africa. On the top, it's to the east, so Asia and Australia, and to the bottom, so -5, -6, -7, that's America. So there is where you can find everything about your time zone and the surrounding ones. What you see at the beginning are all the lines are quite wild. This was always the local time zone at those places, and then they were concentrated into plus or minus 24 different levels. The small ticks that you see are daylight saving time, and there are some huge jumps that are some Pacific islands that change the whole date because they just jumped from one side of the date border to the other one. This is the detail of all US time zones. The ones at the beginning are Alaska that moved from east to the western hemisphere. What you see here is that all the ticks, they continue up to 2038. This means that with the current version of time zone database, your computer will always jump between the daylight saving time, even if the government decides that it should be different. So if you think that you have a perfect program and testable and in Docker, and you don't touch it anymore, this is what it will do with the local time. So update your time zone database. These are all the US time zones, so you see that there is a huge concentration in Indiana, and there are several time zones in Alaska. Indiana has over 300 different regions that in the past century to some point had a different time than another one. Fortunately, most of the changes happened between 1970. That's why the current time zones are based on what has happened since 1970. So this is not reliable for time before 1970. So if you use American New York time zone, don't use it, don't rely on that for times in Ohio before 1970. The information for New York looks like this. So there you see that between 1883 there was local time of New York, not of Ohio. And then later they used some rules that are defined somewhere else. So this is the New York rule for the 20s and for the 50s about daylight saving time, and these are the US rules. You see during the war, World War II, there was daylight saving time first called war time, and then it was changed to Eastern Peace time. This is the information or the graph how the daylight saving time in those few American time zones looked like. So you see that it was not everywhere at the same time. So at the beginning in the 40s, 50s, 70s, only about a third of all time zones in America used daylight saving time, and even then it changed from one to another. So probably it was Indiana and these regions that decided to start with the daylight saving time or not. This was even worse elsewhere in the world, because what's important is that if the government decides to adjust the daylight saving time policy, they should announce it in advance. And if you read those files in the DATASET database, you will find cases of countries that even in the past 10 years with modern airports and other systems that need to use some standard system of daylight saving time, that these governments decided to start daylight saving time one day or 1 week later, or they decided to abolish or stop using daylight saving time in the respective year at all. So that's a lot of interesting reading in those files. So have a look at them, and please don't invent your own time zones. Don't hard code any rules. So like it's the last Sunday of November, I'm going to do something. No, use the standard library. Keep your time zone slips up to date because they change several times a year. And follow your government's intentions to modify your time zone and inform the DATASET IANA.org mailing list. You will get famous. And please, if you can, avoid the time zones at all. Thank you very much.
Hi, welcome to this PyOhio 2020 Lightning Talk. I'm Kimberly Fessel, and it's time to fire up your flux capacitor and put on your life preserver because we're about to take DeLorean for a test drive. DeLorean is an open source library developed by Madi Youssef to help you work with date times in Python. You can install it by executing pip install DeLorean and then load it into your Python scripts with import DeLorean. Now that that's done, let's take a look at some of DeLorean's features. By the way, you can access all of the code I'm about to show you via Google Colab with this link. Once we get our DeLorean fired up, we can go ahead and import and create an instance of a DeLorean object. Once we print that out, we'll see that this is the current timestamp, but it is in the UTC time zone. If you'd like to shift that, you can just use this shift method, and now you'll see that my hour has been updated and my time zone has switched to US Eastern. DeLorean is also nice in that you can access the different components of that DeLorean object, for example, this naive timestamp, the date, or you can switch over to Unix time with this epoch property. You can also replace the parts in your DeLorean. For example, you could switch your hours to be 10, or you could go back to Marty McFly's time and switch your year to 1985. DeLorean also works with date times time delta, so you can do time arithmetic. For example, you can go 3 weeks forward in the future, or you could subtract off 2 minutes and 10 seconds to roughly when you started this video. We are off to a great start, and it didn't even require 1.21 gigawatts of electricity. Besides those basics, there are 3 more DeLorean techniques to tell you about: parsing date strings, creating regular time intervals, and describing time with natural language. Let's take a look. Parsing time with DeLorean is super simple. You just need to import the parse module and then supply whatever string you're interested in. DeLorean will convert that string into a DeLorean datetime. And you can use many different string formats, which is super useful if you are collecting information from various different APIs, or if you're doing something like web scraping. You can also use DeLorean to create stops at regular time intervals. First, import the stops module, and then stops is going to give you a generator that you can iterate over. You just need to supply the frequency at which you like the stops and then how many of those stops to create. So here I've created 2 stops, starting with the current timestamp and then forward 1 year. But you can also use DeLorean to specify which time intervals you're interested in. So here I've set a start and a stop interval, and I've even said that I'm only interested in Mondays. So here are my 2 Mondays during this time interval. DeLorean allows you to talk about time using natural human language. For example, if I want to know the date of last Thursday, or I can supply an integer and move forward in time 30 years. DeLorean also has this humanized method so that you can contextualize any DeLorean datetime in terms of your current timestamp. When it comes to datetime manipulation in Python, you have lots of options, including arrow, pendulum, and the blazing fast udatetime. Your choice of library ultimately comes down to your project's needs and your own personal preferences. DeLorean attempts to compile and enhance some of the best bits of other libraries, so I hope you've enjoyed getting a glimpse at what this DeLorean can do. Thanks for joining me, and like Dr. Emmett Brown says, if you put your mind to it, you can accomplish anything.
Hi everyone, I'm Sumana Harihareshwara, and this is Apply for Grants to Fund Open Source Work. When I tell people about grants they could get to help them work on their open source projects, sometimes they're surprised because they didn't know such grants existed. So I'm going to talk about a few of those funders, give you a quick case study on how the Python Software Foundation got some funding to improve PyPI, share key steps in case you want to apply, and tell you how the new Project Funding Working Group at the PSF can help you along the way. And all of these links are in the PyOhio talk description page. So first off, yes, these grants exist and these opportunities are real. There really are companies and nonprofits and governments out there giving away free money so people can pay the bills while improving your existing open source software projects. I'll describe a few, and links to all of these are in the PyOhio talk description page. NLNet is a foundation in the Netherlands. They give away money to open source projects in network and internet engineering or that advance privacy or search. They've funded some Python projects such as reproducible builds, and you can apply anytime. The Chan Zuckerberg Initiative has a funding program happening now called Essential Open Source for Science, where they want to fund open source software projects that already exist and that are essential to biomedical research. I noticed this last year and suggested that the PSF apply. We did successfully, and they are one of the funders for the pip dependency resolver work that I'm managing this year. Comcast has an innovation fund that can fund up to $150,000 US for one-year projects. They want to fund projects that have something to do with networking and broadband. Mozilla Open Source Support makes awards to existing open source projects that support Mozilla's mission, the open web, or that Mozilla relies on, or that are widely used and need security audits. Moz funded the overhaul a couple years ago of the Python Package Index, or PyPI, which I worked on, and they are the other funder for that pip dependency resolver work that's happening this year, along with CZI. So here is a little case study. The Open Technology Fund is currently going through a rough time, but I won't get into that right now. I'm going to talk about the money that they awarded to the Python Software Foundation so that last year we could make some improvements to PyPI. I won't call this a grant because OTF awards are performance-based contracts, but it's a lot like a grant. In February 2018, I suggested that PSF should apply to the Open Tech Fund for money to improve PyPI's security and accessibility and work on localization. The deadline was March 1st. So we started work on an initial proposal, what OTF calls a concept note, figuring out what we would want to do and how much time it would take and how much that would cost. People who already knew a lot about the software and had experience with contracting rates made some guesses. We made a lot of revisions to the concept note all the way up to the application deadline to make it clearer what we would do, how we would do it, and why and how these changes would benefit lots of users. We asked for $80,000 for a 5-month project. We submitted that concept note on March 1st, 2018. On March 12th, we got an update saying we'd get a formal determination within 2 to 3 weeks. Then on April 12th, we found out they liked our concept note. Now we needed to give them a more detailed proposal with a budget breakdown and answer some questions. We did that in April, then answered some more questions in June. Then on August 1st, they said they needed just one more clarification. We gave that. As of August 29th, we found out we were heading into compliance, which meant we were approved and could start planning the start date and hiring contractors. So that took about 6 months all in all, and some funders are faster than this. For instance, Mozilla Open Source Support has more like a 2-month turnaround. The PSF used a request for proposals process to hire contractors. We started that in October 2018 and ended up extending the request for proposals deadline to January 31st, 2019 to get more proposals. Contractors kicked off work on March 11th, including me. We ran into some delays and work took more like 8 months instead of 5, finishing up in October 2019, but we stuck to that budget and we finished and deployed those improvements that we had planned, and they are live on PyPI now and everyone can use them. So now I'll talk about some key steps in figuring out a good project idea, budgeting, hiring, and submitting a proposal to get help funding your already existing open source project. A good idea is clearly wanted, for one thing. There's already consensus among project maintainers, and you are not waiting for a policy or architecture decision before you can implement it. It's fairly well scoped. You can define what success will look like. Revolutionize ebook lending is badly scoped. Add this DRM-free lending library to these browser extensions is well scoped. A good idea is fundable. It would happen much faster if you got funding to implement the work. So it has to be legal and physically possible. So reverse engineer and re-implement iOS probably fails this test. And a good idea has a theory of change. You have an assessment of what your user's life is like now. You have a vision of how their lives could be better, and you have a suggested course of action that would help get closer to that vision. Budgeting. Start by thinking about what goals you want to achieve, what funders are willing to pay, and how much work you can do with that money available. So let's say you're thinking about Mozilla open source support. With MOS, you shouldn't count on getting more than $150,000 if you're funded. Probably most of your money will go to wages, maybe some fraction of it for hardware or similar expenses, and if we can travel again someday, travel. If you're hiring in the US, say for skilled Python developers, assume you'll be paying somewhere from $80 to $200 per hour. So let's say you're just paying for labor, $150 an hour, $150,000 turns into 1,000 hours. If someone works 35 hours per week, it's about 28 weeks, which is about 7 months. As you're budgeting, make sure that you make time for ramp-up time for the laborers, not just for new folks. You may need some setup time as well. Talking to your users about what you're doing before and as you do it. Responding to bug reports, old issues that you'll look into during the work and new ones that come in while you're funded. Writing and updating documentation. And publicizing once you're finished. Blog posts, a report for the funder, mailing list posts, and conference talks. Sometimes people think money won't help a project because all the existing maintainers work full-time already, but money can help hire someone new to help. If you budget for ramp-up time, a new developer can become a reviewer and contributor, and you can hire help with bug triage, security audit, improving continuous integration, user experience, research and design, documentation, and general project management. As you write your grant proposal, even if the funder doesn't ask, start to make notes about who will do the work if you get funded. Is it you? Is it a team? Will you need to hire people? If you can't do it all yourself, what skills do the other people need? Having that role description will help a lot if you need to talk to your network and get recommendations to hire someone. When writing and submitting your proposal, the details count. You really do have to answer every question they ask and meet their deadline. Try to submit it at least a day before their deadline, just in case there's a snag logging in or uploading an attachment. Finally, I'm part of a volunteer working group that reports to the board of the Python Software Foundation. We are the Project Funding Working Group. We just launched a few weeks ago, and we help you get funding for Python-related work that benefits everybody. The Project Funding Working Group researches and advises Python community volunteers on applying for external grants and similar funding to advance the mission of the PSF, which includes but is not limited to things such as advancing the Python core, Python-related infrastructure, key Python projects, and Python education and awareness. So we provide, or are getting ready to provide, since we just started, several resources at our GitHub repository. A list of funders, ideas for fundable projects, reusable grant application materials. And you can ask us for advice on creating budgets, submitting proposals, hiring, drafting reports, keeping funder relationships healthy, and more. Email us anytime. Our contact info is on our homepage. I also have an independent consulting business, ChangeSet Consulting. You can hire me to assess your project, suggest funders, and write or edit a grant proposal, or as a project manager for your grant-funded project. Thanks, and I hope I get to talk with you soon.
Hello, my name is Gabby Leo, and I'm a data scientist at SenseCorp, and I want to welcome you to my PyOhio lightning talk on creating a custom chatbot with Python and Azure Bot Services. My contact information is currently on the slide, gleo@sensecorp.com. I love connecting with fellow Python and data science enthusiasts, so feel free to contact me with any questions after the talk, but let's go ahead and get started. Here's a quick outline of my talk today. I'm going to start with a chatbot overview, touching on why chatbots are important and how they work. Then I'll move into a comparison of different chatbot platforms across multiple attributes, taking a deeper dive into one of the platforms, Azure Bot Service, pointing out key features and add-ons, and then I'll wrap up with a sample chatbot architecture diagram, as well as a quick live demo. So let's jump into it. Why am I talking about chatbots today? They have become increasingly popular, and almost every website that you go to that is offering a service, chatbots are being implemented to mimic a human-to-human interaction, but now using a human-to-machine interaction. So why are companies doing this? Put simply, it's to streamline the interaction and enhance the customer experience, which happens in two ways: by improving the customer engagement process and improving operational efficiency, which in turn both lead to a reduction in costs across the board for customer service. We've all waited in a long queue to talk to a customer service representative just to ask for a simple refund or to cancel our account. Chatbots simplify these interactions along with even more complex ones, freeing up the call agents to work on other initiatives and saving the customer time down the line. The question still remains though, how do we mimic a human-to-human interaction with a machine? Let's take a dive into how chatbots work. At the core of a chatbot are two different tasks: a user request analysis and returning the response. Looking at the diagram on the screen, you see that the user sends a request and that input needs to be analyzed to pull out specific intents and entities, and then the chatbot creates a response off of those intents and entities and sends that response back to the user. This loop continues until the user's requests are complete. But what are intents and entities, and what types of responses does a chatbot give back? An intent is just what it sounds like, the intention of the end user. Let's look at an example to make this clearer. If the user says, "Show me yesterday's financial news," the bot would classify the intent as to retrieve a list of financial headlines, and intents are given a name, often a verb and noun. So for this example, the intent name would be "show news." Now, you might be looking at that and thinking some information might be missing from that intent, such as, okay, we know we want news, but from what day and what type of news do we want? So this would be what we called entities. These entities in this specific example would be identified as yesterday and financial. And they would be given names like date time and news type. So if you think about it, this can balloon and explode pretty quickly, with many intents and entities needing to be recognized by your chatbot. And on top of that, there isn't a one-size-fits-all response to every intent and entity. Sometimes your bot can respond back a generic and predefined text. Sometimes it's using a knowledge base, which has frequently asked question and answer pairs to return the answer to a question in that list. Other times it needs to access data from your enterprise system or even ask a follow-up question to get more information from the user. So with so many different intents and entities for different domains, along with multiple different types of responses, thinking of how to build a chatbot can be really daunting. But tools exist out there to get you started. So let's take a look at some of these tools and how they compare and contrast against each other. This graphic is displaying 4 of the most common types of chatbots out there, in order from the most complex to the least complex. On the left side, you see building from scratch, which is going to be the most complex. Comparing across different attributes, you can see that the level of effort and time to implement a from-scratch solution is going to be really high. You're going to need to bring your own data, and in terms of scalability, it's going to be tough as you're going to have to build out every new piece of functionality from scratch. The benefits of this option, though, are that the long-term costs are low, you aren't using a service or platform to help you, so you're really only paying for the development costs, and you have complete full control over your customization. On the far right side, though, in contrast to that, is the least complex option, which is AIML, and that stands for AI Markup Language. This is going to be an exact string match or lookup. So in terms of customization, think very low. You're only going to get a static response, and that response is only going to happen if there was an exact string match. There's no brain power to this chatbot. Plus, scalability is going to be really difficult because you have to add in every possible question you can think of that your user would want to ask for each domain. So imagine trying to build out a new domain using AIML. The benefits, though, are that the level of effort and time to implement are low, as well as the data size requirements for the long-term costs. The middle of this diagram is the sweet spot, so it pulls from the advantages of both extremes and minimizes the disadvantages of both. Dialogflow is Google's chatbot platform, and Azure Bot Service is Microsoft's. They are both faster to spin up than building from scratch and come with pre-built domains, so you don't necessarily have to bring your own data depending on what you're trying to do. They are both fully customizable and have add-ons which can make scaling in the future super easy. The only thing to note is that in terms of cost, you will be paying more for these solutions as you are using a service. But the flexibility of customization, along with the ease of use to spin one up and the integration with other tools, make these the clear winners in the space. So let's take a closer look at Azure Bot Service to fully understand what I mean by flexibility of customization and why this is so important. To start with, Azure Bot Service integrates with some of Microsoft's add-ons to get you off the ground and running quickly without having to write custom NLP code. Lewis helps identify intents and entities for pre-built domains so you can create your own custom domains. The picture in the top right is showing an example of Lewis using the home automation domain. If you choose this as your domain for your chatbot, it would have pre-trained models to pick up intents and entities, so when your user sends a request such as turn the right light on, Lewis would return the intent is to turn on with 90% confidence and that the entity related to that intent is the right light. It also integrates with Microsoft's Q&A Maker, which is the knowledge base I referred to earlier. You just have to upload an Excel sheet with your predetermined frequently asked questions and their answers, and Q&A will train a model on the click of a button to respond to the user with the answer that corresponds to the question the user asked. In the future, if you want to scale your chatbot to voice assistant, there's a speech-to-service tool you could add onto the framework. And lastly, there's a text analytics API, which allows you to detect sentiment from a sentence. So there's a lot of out-of-the-box solutions to get you up and running pretty quickly. Plus, if none of these options work for you and you have a complex task you need your bot to carry out, you can use the Python SDK. From building a Q&A bot to your own branded virtual assistant, there are many templates out there that you can download to get started and a ton of documentation online to keep you going, giving you a template to work off and pre-built functions to interact with the user. The pain of building from scratch is taken away, but you're still able to customize and write and train your own NLP models to pull out exactly what you need from the user's request and respond all natively in our favorite language, Python. Let's take a look at what an example chatbot architecture would look like using all that Microsoft has to offer. First, the user sends a message, which can be on any platform that Azure Bot Service integrates with, such as Teams, Skype, Slack, or even a personal website. The message is sent to your Azure Bot Service instance, and firstly can be run through the Q&A Maker to see if the user has asked any of the questions in your frequently asked questions list. If it's not in there, it can then be sent through Lewis, who will try to detect any intents and entities associated with any of the pre-built domains or custom domains you have created. If this also turns up empty-handed, we can then use our custom NLP in Python, which includes text preprocessing, such as removing stop words and lemmatizing the text. We'll encode and vectorize our text, create our feature vectors, all to understand what the user is saying. In this example, the custom NLP detects that the user wants to search the enterprise system for a specific document over a topic. So vector comparisons are made across the user's input and the document library to return the most similar documents, and the user then gets a list of the top 3 documents pertaining to that topic. As you can see in the custom NLP section, anything can be done here using Python, think sentiment analysis, topic modeling, document search and retrieval, plus many more. You're no longer limited to frequently asked questions or intents and entities in your domain that Lewis recognizes. So let's see this in real time. I'll be showcasing an Echo bot today, which can be used as a starting point to create a custom NLP bot. Let's take a look at the bot script. In this script, you're creating your bot. So this is where you would add in all the custom NLP. Our simple bot just returns you said and whatever, and you can see that here. But what you can also see is that you're not having to program the functions to understand what the user said or what the user's input was. These are pre-built functions that come with the framework, which is awesome and saves you a lot of time. Then we have our main script, which is app. This is where you call the instance of your bot and create the app your bot will be on. You open up a new terminal and run the app script, and then we open up the bot framework emulator to test out our bot. So let's give it a try. So here we're going to run our app. Then we're going to open our emulator, connect it to our bot that's running right now, and go ahead and test it out. So as you can see, from my code here in my bot instance, anytime a new member is added, I want it to say something, right? So for this example, I want it to say hello and welcome to my PyOhio lightning talk. So when I open up my emulator, that's the first thing that you say. If I want to respond back to the bot and say, hello, PyOhio 2020 is awesome, as we saw from what I programmed, the only thing it's going to return is the echo. So you said, hello, PyOhio 2020 is awesome. But as you can see, look how easy and how little code this is for you to then go ahead and add in all your custom NLP in here to make it do whatever you want when it gets a user's input. So if you take away anything from this talk, the 3 things I want you to go away with here are that the flexibility, ease of development, and ability to scale in the future for Azure Bot Service are almost unmatched in the market and can get you started quickly in the language you are most familiar with, Python. I want to thank you all for joining me today, and if you have any questions, please feel free to reach out.
Hi, I'm Chris Reinauer, and today I'm going to talk about using Python in the open source game engine Godot. Why use Godot when Unity and Unreal are also free? Without getting too much on a soapbox, I find Godot to be a breath of fresh air. The hierarchy of nodes that encourages composition and the Python-esque batteries included approach enable you to get from idea to prototype incredibly quick. Next question, why add Python to Godot? It's true Godot ships with a Python-like scripting language called GDScript. It's actually pretty great and what I use on many projects. But some projects seem made for Python in the Python ecosystem, especially with procedural generation. We'll be using the add-on Godot Python, which includes a standalone Python environment for us to use. One type of project I believe can leverage the Python ecosystem is a roguelike game. We'll be using the popular TCOD library and some Creative Commons assets from Kenny. So now I'm in a brand new Godot project. The first thing I want to do is get Python. I'll go to the asset lib and search for Python. We'll use the non-PyPy version and start the download. When we install, we'll just choose the platform we care about. After a restart of the engine, we'll add our 2D scene. First, I like to rename all my scenes away from Node 2D. Then save. Next, we'll add a script. We can choose Python as language now. And here's our basic script. Save again. Now let's get our assets in the engine. Drag the tile map from our Kenny assets onto Godot to import. We can now see it in our File System tab. Next, we'll need a tile set to tell Godot how to use it, which I've already created off camera and you can get from this talk's resources. Now, let's add our Godot tile map node. We'll attach our tile set and can immediately see our available tiles. Next, we'll edit our sizes to match the asset. Next, let's jump over to a terminal inside the Python script folder in the project. We'll run ensure pip and then install our TCOD library. If, like me, you're running this on Windows, you'll need to add Python 3 DLL to your TCOD folder and packages. I've included the file in the talk's resources. Back to our terminal, we can now import TCOD in our project's Python. Inside our world.py, we can now start to use TCOD. We're using the binary space partitioner to generate dungeon rooms. I followed TCOD's tutorial to get this far. I also want to paint the empty tile, number 15, over the whole map. We can see the index of our tiles back in the 2D tab by selecting the map. I've done a very rough and basic build room function to set the tiles in the tile set. First we get a reference to our tile map which I've named structure. Then we loop through the outside coordinates and try and intelligently set the wall tiles. Inside build hallway, I try and layer on a matrix of tiles between the rooms I'm told to connect from TCOD. And here's our first result. Not great, but not bad. We have rooms which are connected, and we let TCOD do all the work. The hard-coded hallways show their limitations here, but that's a solvable problem. One thing I don't like is that grid pattern. Back in Godot, we'll select our tile map that we imported earlier, go to the Import tab. We'll disable filtering, re-import, and run the scene. This generation looks even better and has no grid. I hope you've enjoyed learning a little bit about Godot and Godot Python. If you have any questions, please don't hesitate to reach out. Thank you.
Hi everyone, I am Niharika Krishnan and today we'll be talking about what happens behind the scenes of spell checks. So before we get started, a little bit about me. I am a machine learning engineer at TCS in India where I work on building chatbots using natural language processing. Off work, I contribute to the Python tech community as a speaker, mentor, and also by organizing the PyLadies Chennai meetups. With that, let's get started with spell checks. So what really is a spell check? It corrects, it's a functionality which detects and spelling errors and possibly suggests alternatives. And based on the best alternative, you have an autocorrector which automatically replaces the wrong spelling, right? So there are different algorithms which govern this spell check functionality, and we will be going through each such algorithm and understanding how they differ and understanding where to use what. So a spell check is something which is which is part of the natural language processing pipeline. It falls under the data pre-processing, and you will find use cases everywhere, be it your mails. So this is just a small stat that there were around 269 billion emails which were sent in the year 2019, which averages out to around 20 mails a day. And I think during this COVID situation, this number is much, much higher. Imagine you face a situation like this, right? So you will also find spell checks in search engines, in recommendation when you're making a spelling mistake in your doc, or even in chatbots. So these are all the places, including text mining and all of it, where spell check is very crucial and integral. There are Python packages already like Spy, Spell Checker, TextBlob, NLTK, which already have functionalities like the correct function or the unknown functions, like this spell checker object or the edit distance function, where you need to give the strings and it corrects it for you. But there are these algorithms which depend on edit distance, which runs behind, and we will understand how it changes CMPUTR and how it is able to detect the word computer out of that, right? So what happens behind the scenes? So this is a concept which is known as edit distance, where it is basically, it quantifies how dissimilar two strings are. So to take an example, you have the word intention and execution, and you have different operations like insertion, deletion, substitution, and transposition. So to convert this word intention to execution, as you can see, there are almost 5 operations which are required. So the edit distance for this is 5. So based on these 4 operations and the permutation and combination of using these 4 operations, different algorithms work. And so the first algorithm which we're going to look into today is the Levenstein, which is working on the insertion, deletion, and substitution, followed by the Demerol-Levenstein, and then the least common subsequence. So the difference between the first and the second is the operation which is transposition. So to take an example, for the first one, you have 2 words which is receive and receive, which is IE and EI. This is a very common mistake which we do, all of us, right? So the edit distance, that is to convert the wrong one to the correct receive, is 2. But the same edit distance for the same 2 operations, you can also convert it to the word receipt, RECEIPT. So these 2 are very different semantically, and they are used in very different contexts, right? So this is a small drawback with the Levenstein algorithm, and to correct this is where we have another one which is called as Demerol-Levenstein, which also includes the operation of transposition. So transposition is something where you do character swapping, and so this has a much higher probability and accuracy. Another one which is used is called the least common subsequence, which only takes into account an insertion or deletion. Just to see how this works and how they differentiate, let's take an example of kitten, which needs to be moved and converted to the word sitting. So the Levenstein algorithm is the one which is on the left, and the LCS is the one which is on the right, and as you can see, it takes 3 operations and the one LCS takes 5 operations. So Levenstein is definitely a much better approach, but it is again depending on your use case as to whether you would like to go ahead with LCS or with respect to Levenstein. So another few algorithms which you need to take into account is Hamming distance, Jarrow, and Jarrow-Winkler. Hamming distance only focuses on substitution. So if you have a use case where both the strings are same, and then you would want to see how dissimilar they are, that is when they are of the same length. So you can definitely use Hamming distance. Jarrow and Jarrow-Winkler are pretty amazing when you have multiple words. So when you have 2 or 3 words and you want to see their similarity just by using edit distance functionality, it uses only transposition and matching characters. So insertion and deletion, there are a lot of operations which take place. So when you only talk about transposition and when you talk about matching characters, you get a range of 0 to 1. So 0 is the least similar and 1 becomes the most similar strings. So you get this probability, and based on that you can decide. Jaro-Winkler is an enhancement to Jaro where it also takes into account the prefix. So if you have a use case, for example, where you need to autofill, or you have your start menu and you are typing an application name and it predicts the probable application names, that's where your prefix remains the same. So that is taken into account, and Jaro-Winkler works amazing there. So there is a package called Jellyfish, and there are multiple other packages also where you can just call these functions, these algorithms, and give the two strings and give you the output. So the first three give you the edit distance as your output, and the last two, which is Jaro and Jaro-Winkler, give you the similarity ratio between 0 to 1. But this is something, this algorithm which has recently come, which is symmetric delete spelling correction by a person called Wolfgang, beats all of them, and it's 1,000,000 times faster. How does that happen? So SymSpell, which is actually the package which uses this algorithm, uses only the concept of deletion. So it has a frequency dictionary, and that is a frequency dictionary which you can build based on the corpus. It contains words and the relevant times it has occurred in that corpus, that there is a number of times. So what it does is, it doesn't just operate on the input entry, it also operates on the frequency dictionary. So if you have functions like insertion, deletion and substitution, it does delete on both. So if you have, just to give you one small example, if you have insertion function and you are given the input entry as GOA, so you can, it deletes a dictionary entry from which has proper words like GOAL if you have an edit distance of 1 and you delete it. So that basically gives you the word GOA and it matches. So this is how symmetric SymSpell works. So instead of generating 3,000,000 possibilities, if you have a 5-letter word, it generates only 25 possibilities, and then you get to choose the best one out of it. So when you take the example of substitution and transposition, it does deletion on both, on the input and as well as the dictionary. So if you see, it will delete one character from here, and it will also delete one character from here. So the K goes out and the L goes out, and then you equate GOA with GOA. So you do get suggestions like GOAL and GOAT are probable suggestive spellings of the spelling error, which is GOAK, right? So here's just a small brief as to how SymSpell, you can invoke it and you can work it. All three main things which you need to do is load the frequency dictionary, and you need to give the edit distance length which determines how many operations you are able to do on the dictionary. And then you have two functions, which is the lookup function and the lookup compound. Lookup is when you have one word, and lookup compound is when you have a string of words, when you have a lot of words, right? And so this helps in word segmentation. All you need to do is give the input term, give the verbosity, which is do you want the top suggestion, the closest suggestion, or all suggestions, and you also need to give the edit distance. So be it 1, 2 or 3. Based on that, it will give you the suggestion to terms and the distance and the count, that is a frequency count. So these are the two functionalities, and there is another which is word segmentation, which you can leverage, and it has helped us in our use cases so far, and I hope it helps you too. So if you would like to explore further on this spell check, feel free to connect, and thank you.
MapReduce in 10 minutes. Let's go! My name is Evan Smith. I'm on Twitter and I have a very low activity blog. I really enjoy connecting with folks, so feel free to look me up and reach out. We're really here to talk about MapReduce though. So map and reduce are individual words that have definitions. We'll talk about what they kind of mean in functional programming, and then how they allow us to process big data in an efficient way. Functional programming is a programming paradigm that they call declarative, and that's as opposed to imperative statements. One of the main goals of functional programming is to not alter a business object's state. We would really not ever take an object, do something to it, and then use that object again. what we would do is take an object into a function, do some stuff, and give you a new object. So what this really requires you to do in functional programming, or it rather encourages you to write simpler functions that can be reused and then compose multiple functions to get your desired output. Map simply means to filter and sort. And I think that's the end of the talk. Just kidding. So we have all these Scrabble pieces, and there's not a lot we can do with them in this state. We need to organize this chaos. So what map would do is it would go through each letter in the pile of Scrabble tiles. It will give you what I would call a dictionary, but it will give you this listing of here's A, and here's how many A's there were. Here's B, and here's how many B's there were. So we got 2 A's, 6 B's, 2 C's, 2 D's, whatever. I mean, this is the output of the map function. So it takes a scrabbled, I guess, mess of tiles there and maps them out so you know what you have. I will say, for those of you who already know what map and reduce do or are familiar with functional programming, this isn't 100% accurate. Now, really this looks like the result of a map and a reduce, but here's the difference. Map is going to map each letter out into its own element. So really, instead of A, 2, you would have A, right? Well, I didn't really want to show it that way. So we'll say, for our purposes, that we know that a map gives you A, B, 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 C, C, D, D, yada yada, right? Map takes the pile and separates the letters out. But I did want to illustrate here that there's 2 A's. So say that we have 2 of these piles of Scrabble tiles, and we're going to map them both, right? Well, now I have 2 separate result sets of A's, B's, C's, and all these. Well, that really seems like what I started out with originally, right? I have some things, but what I want to end up with is kind of a summary of those things, right? I want to know how many A's I have in total, not how many A's in pile 1 and how many A's in pile 2, because I have n number of piles of Scrabble tiles, and we need one listing instead of multiple listings. Well, that's where reduce comes in. So all reduce is going to do is just summarize, and it works really well with map, and that's why a lot of times you hear map and reduce together. It's just going to summarize the multiple listings we have from map. So how does it do that? So on the left side you can see that we have 3 different maps coming from 3 different piles of Scrabble tiles. We can reduce those into a single listing, right? And these are really key value pairs, right? You may have noticed from before, I was talking about a dictionary. Your key is your letter, and your value is the count of how many times that letter appeared in the pile. So when we have 3 collections of key value pairs, we want to reduce those into a single listing of key value pairs. So as you can see on the left side, we had 2 A's in the first one, 1 A in the second one, and no A's in the third one. Well, that reduces down to 3 A's because it just adds them up, right? Well, now we have to talk about how this is relevant in big data. So let's do that now. Big data is a thing, right? It's a problem to process so much data. If it's a data set that's larger than can fit on my laptop, then I'm surely not going to process it on my laptop. So we got to figure out how we're going to do this. You could get access to a supercomputer and have just amazing hardware packaged into one computer, but that's not really going to be cost effective for most people and organizations. So what we want to do is we want to distribute the compute across multiple different computers. So if you can visualize a situation where we got map and reduce that work together to filter and sort and summarize, that's what we're going to do with a distributed file system processing big data. If you can imagine a single pile of Scrabble tiles that is huge, we're going to split that single big pile into multiple chunks of data. Now, really your input could be a single huge chunk or it could be several different streams of data that are coming into our processor here. But the concept is that in any case I can split into more manageable chunks of data. Let's say that I was using 3 of my laptop to process my data. I could split the data into chunks that were sized for my laptop. Each of my laptops are going to do a map operation. In the context of big data, a lot of times what we do is we shuffle that. So we take the result of those maps, we got the key value pairs, A2, A1, and then no A. We're going to shuffle those 3 map results into a different structure here. We're going to say, okay, of my 3 map results, I've got A of 2, 1, and 0. B was 6, 0, and 8. It doesn't really matter which map or which split these came from. What matters is we're transforming the data that was in our original huge input that got split and mapped into a form that we're going to be able to easily reduce. Then once we've got it shuffled, we can reduce it into, well, what's the sum of my A's? Well, it's 3. What's the sum of my B's? It's 14, and so on. Each of the letters in the shuffle is kind of separate. Each of the letters in the reduce is separate. Well, your output combines everything in your reduce to be one set of key value pairs again. So your input is this jumbled mess. It's a ton of data. We can split it and process the map on different computers. So that's the distributed nature of the system. We shuffle those around, get them in an order that we can figure out. We reduce them, and then our output is the shape that we needed it to be. Here's a different example of it. Say we were doing some word count processing. We've got say the Internet Archive. So we're going to get a couple things out of this. Our process is going to give us an exhaustive list of all the words in the Internet Archive. It's going to give us a word count of each of those words. We start with this input, so we're just going to split those up in the algorithm split does not matter, but we're going to split them up in some manner. Here it's doing it by line. We're going to map these out. You see the first green box is kind of mapped into Deer 1, Bear 1, River 1. It's simply counting the different words there. It's just mapping them on a one-to-one basis. So then we go to shuffle that. It takes the result of all the mappings and combines them by word, right? And so that's going to be our key is the word, and then we'll have a list of counts. And so Bear 1, 1, etc. That's the orange boxes. We'll reduce that into Bear 2, Car 3, Deer 2, and River 2. This red boxes, and then our final result is a list of the key value pairs. Alright, so how do I leave this talk and go implement MapReduce? What you would do is you would go out to Apache Hadoop, look at their implementation of MapReduce. MapReduce is algorithm. Hadoop is an implementation of that algorithm. Alright, so these resources will help you get started with Hadoop. The first one here is Hadoop documentation. The other place that I would go is IBM Analytics. In association with IBM, there's a website called cognitiveclass.ai. And then I found that on Talend, there's actually a pretty good article.
Warm greetings to everybody watching this lightning talk called Brain-Computer Interface. 1 in 8 people in US alone suffer from speaking disorder like muteness. Statistics related to other speaking disorder and autism is quite disappointing as well. There are lakhs of people out there who, because of such biological disorder, cannot effectively communicate with ease like you and I can. Don't you think these people have the rights and should be able to communicate effectively like you and I? If you think they should, and I hope you do, then I've got a great news for you. As a result of rapid development in artificial intelligence, today we have technologies like brain-computer interface, which is working towards providing voice to the voiceless. So what exactly is brain-computer interface and how does it function? To understand BCI, we first need to understand the basic working of human brain. Because as the name of the system suggests, it is centered around the functioning of human brain. Now, human brain is one of the most mysterious and complex system that is yet to be completely understood even today. But fortunately, we do have enough knowledge of working of brain to build technologies like brain-computer interface. So, every time a human thinks of something, and that something can quite literally be anything, there is series of electrical changes in signals happening in your brain. Let us understand this better with an example. When you are hungry, you think about eating. Now, this thought of hunger and eating causes a series of change in electrical signals in your brain. Further, every time you think about hunger and eating, there is almost always similar change in electrical signals. So all we have to do now is record these changes. And how do we do that? Again, thanks to technologies like EEG, which provides these devices that is mounted on your head, which tracks and... So this is how we are going to build our data set. You have a thought and you have corresponding change in electrical signals in your brain caused by the thought. So here, in this case, hunger is the change that it caused. So hunger is your output or label, and XYZ, the change that this caused, is your feature. Similarly, say you feel pain. So pain and thinking, and this thought of pain causes a certain change in electrical signals that becomes your feature. So there are millions of thoughts or action that you think is possible. As a result, there is possible. All we have to do is record all of this and build our data set. Once we have built our data set, we use DNN to train and build our... What's more fascinating is that we can have these models up and running within a day or two thanks to high-level Python frameworks that we have available today. Frameworks like CV and libraries like EEG that is specifically built for this purpose. Now BCI has wide range of applications. It provides voice to the voiceless, it can be used in security systems, it can be used in criminal investigations and many other places. But unfortunately, we are still at least technology into wide use in the real world because of certain limitations that it has. What kind of limitations? Say, we have limited number of data set has best. And one of the larger problems that this technology runs into is that of ethics. What ethical role does this technology exactly play? Since this is the CI and basic functioning of it, but there is a lot more detail about the functions of BCI. If you find this idea even slightly interesting and fascinating, there is good amount of literature available online on the internet on BCI. Please do have a look at it. Signing off, this is Hitesh Khandelwal. I'm currently a student pursuing Bachelor of Science in Computer Science at Ashoka University. Thank you.